Hi everyone. So the topic today we will be discussing is the difference between OSI versus TCP/IP model. So before starting this session, guys, let me tell you one thing. Like today, you all know that we are all connected with each other, and we are sharing files, transferring the files, deleting the files over internet, uploading data, downloading files over internet. So for example, let's say if you are downloading some files, let's say if you want to download some files over the internet, so you are using the post office protocol. If you want to transfer some files over the internet, you are using FTP protocol. If you want to send some mail, you use SMTP protocol. Like if you want to, if you want to browse the internet, so you use HTTP protocol. So like there are lots of various protocols and over the internet, right? So what, like at the beginning of internet, there were many companies which were creating their devices. Like for example, Apple was also there. Apple was creating their own devices. IBM was also there, which was creating their own devices. HP was there, Dell was there, and so on. Like many companies were there, which were creating their own devices. So, see, like these companies were creating their own protocols as well. Like Apple was creating Apple Talk, IBM was creating DECnet, and HP was also creating their own protocols. So, for example, now by this, what I want to explain you is that if Apple wants to transfer data, for example, we have two machines.
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
Here we have two Apple machines. Let's take a scenario. Both are interconnected with each other. So this is PC1 and this is PC2. So if Apple wants to share some data with PC2, so if the next machines, like the both of the machines are of Apple, then the communication is possible. But let's, for example, let's say if this machine is your Apple machine and this machine is your IBM machine. So in this scenario that they won't be able to communicate with each other because they were having their own protocols, like they were creating their own internal protocols, which were not standardized, which were not standardized over the internet. So in this scenario, when the network was growing rapidly, it was creating many problems. Like in these kinds of scenarios, the protocols were not internally working with each other. So to remove this drawback, this OSI model was developed, like to make the different communication between different vendors and manufacturers, so that everyone be able to communicate with each other. Like now we are communicating with HP to HP, Dell to Dell. Like apart from that, HP to Apple, you are also able to communicate like throughout any vendor specific. Like it's not there now, so you can communicate with any of the machine. So this OSI model is consist of 7 layers, like whereas TCP/IPs consist of 4 layers. So let's get started with this OSI model. So these are the name of 7 layers. We do have application, presentation, session, transport, network, data link, and physical. So how these layers are going to work? So for that, I will be giving you a very simple scenario to make you understand entire 7 layers, like what is the working of these 7 layers. So let's get started with the application layer first. But before that, let's take a scenario again. Like let's say if we have two computers, PC1 and PC2. This is your PC1, this is your PC2, and both are connected with each other. So now, for example, if I want to send some mail to PC2, let's say I want to send a hello mail to this PC2. So I must be having an IP address, and this machine would be having some IP of its own. So this is my destination and this is my source address. Like PC1 is my source and this PC1 wants to send hello message. But see guys, when this PC1 wants to send a hello message, so it is definitely going to use any kind of application. But for example, let's say we are sending mail. So to send the mail, we must be having Outlook configured, or if you want to send from Gmail or any other web mail, so you can send the mail via that particular application. So let's get started with the first layer. What is the work of your application layer? But before that, guys, these are the PDU units and these are the layers as discussed. So like all these PDU units I'll be explaining you in the last. So let's get started with the application layer. So if you will see that application layer supplies the network services to end user applications. In this layer, user interacts with the application software, which basically means, like as we have taken the scenario, there are two PCs and both of these PCs wants to communicate with each other. So you must be having some application installed on your machine. Like for example, if you want to send me a mail, to send the mail, you must be having a particular specific application. Like you must be having the Gmail, or if you don't have that Gmail application, so you will be going on Google Chrome, Mozilla, Edge, or Safari if you are using. So you have to go on this specific application, and then you have to go on that particular service or on that particular mail where you want to send me the mail. So for example, like we use web browsing, for we use HTTP, and for FTP, like we use file transfer protocol to transfer the data like that. So that data is being traveled over the internet through the applications. Without the application, you are not even able to make the communication possible. So the first step of the OSI model says that application layer, that which provides you a kind of interface through that you are able to communicate over the internet. Now, when the data comes from application to presentation layer, so see guys, the name itself represents that. For example, let's get back to that scenario. This PC1 was sending a message to PC2. This is PC1, this is PC2. And what was the message we were sending? The hello message. Now, this hello message is like, we would be having some application installed in our machine if you want to send the message. For example, we have Gmail installed and we are sending the message. So now it is going to prepare that data. Let's say, for example, if you are sending me a Word file, so it is going to mark that particular data with a extension code. Like it is written, it takes the data from application layer and marks it with the formatting code, because over the internet, what data you are sending will be identified by the extension. So you must be having a particular extension for whatever the specific file you are sending. Like for example, if you are sending a text file, so it will be having .txt. If you are sending a photo, it might be having like PNG or JPG. So like there are lots of extensions for every specific data file which you are sending. Now when it comes to the session layer, so session layer deals with the connection, and more importantly, session layer also maintains and the separate application data from which is different from each other. So let's take an example. Let's say if you are using your computer, in your computer you are using three tabs, like Facebook you are using Instagram, you are using Gmail. So, and now your computer is having the IP of 192.168.1.1. So if you will find that 192.168.1.1 is the source IP now of your machine. For example, like all these IP, for let's say this Facebook will be having its own IP like 1.1.1.1. This Insta will be having its own unique IP, let's say 10.2.2.10, and this Gmail would be having its own IP. So let's say Gmail is having 100.1.1.1. So whenever you are, requesting any data from Facebook, so you will be sending some data over the Facebook. So in that case, when you are sending the data, so your source IP will be the client IP, which is 192.168.1.1. And see guys, as you all know that Facebook is not having a single server in the entire world. So there are lots of multiple servers over the internet. So in that case, when Facebook is also going to reply you back, for example, if you have requested something over the Facebook, so Facebook will also initiate some reply back. So in that case, the source IP might be like Facebook is replying, so the source IP was 1.1. So it may differ, like because we do have different Facebook servers. So let's say 1.1.1.2, we got the reply from this, but the destination will be what? 192.168.1.1, because this is the destination which Facebook is replying to. And when you were sending, the destination was Facebook and the source was you, like which is your client IP. So this session layer basically maintains the separate application data which is different from each other. So basically it also manages three functions like establish, manage, and terminate. So like it is going to establish the connection and manage the connection for you, and then once it has managed the connection, it is going to terminate. Apart from that, it also maintains, like it also checks for the authorization, authentication and somewhat, like for example, if you are using gmail.com, so when you will be logged into the gmail.com web page, so it is going to ask you for the login credentials. And if you have the login credentials, then it will give you the authorization that this is the authorized user. So this is also a part of your session layer, guys. Now, once we do have the transport layer, which is the intermediate layer between the upper and lower layers of the OSI model. So the major responsibility of this layer is to make the communication between upper three layers and the lower three layers. And how it is going to do that? So here it is going to use the connection management, which includes two protocols, TCP and UDP. So like we will be discussing these protocols, like both of these protocols are, defined by the need of the user, like what kind of data we are using. So there are two aspects, like what we are using. If let's say if you are using TCP protocol or if you are using UDP. So the aspect is somewhat like, let's say if you are using, if you are sending some plain text data. So plain text data means like whatever the data, for example, if you are chatting over the internet. So in that case, like if you are going to chat, so you will be using textual data. So that text data will always use this TCP protocol. And if you are using audio video signals, so in that case, your UDP protocol will be used. So like, see, what's the difference between TCP and UDP? That TCP is connection oriented, it's connectionless. TCP is reliable, but UDP is not reliable because it don't follow a three-way handshake process. So apart from all these points, guys, the most important point about the TCP protocol is that it follows a three-way handshake process. And three-way handshake process is somewhat like, which includes, let's say, for example, how does the three-way handshake process is going to work? We have this machine, PC1 and PC2. So first of all, like whenever establishing the connection, this PC1 is going to send a request to PC2, that which request is known as a synchronized request, that I want to establish a connection with you. Then this PC2 in the next step is going to acknowledge that yes, I have accepted your request, as well as it is going to send the synchronized request that I also wants to establish a connection. And then the last step, this PC1 is going to give the acknowledge to this PC2. Getting, guys? So this is how the three-way handshake process is going to happen in case of your TCP protocol. So that is why it is said that TCP protocol is a reliable protocol, because it is going to give you the guaranteed ordering of the message, and it is a heavyweight protocol, as well as it is going to take care, of all the sequencing of the message, like whatever the text data you are sending. So it is going to deliver that data in the sequence, but UDP does not deliver that because UDP do not follows the three-way handshake process. So this is basically the major difference between the TCP and UDP. So it's always remember, like TCP is always used in case of text data transmission, but UDP is also used in case of your audio video signals, like where you are exchanging audio video signals. For example, if you are going live over Facebook, if you are going if you are going live over Instagram, and if that particular stream will always use the UDP protocol. So this is what the work of transport layer is. Now we do have the fifth layer, which is your network layer. So they see, guys, what is the major responsibility of this layer is that it is going to provide you logical addresses, and the router is the device which is going to work on this layer. Now see, guys, the main functions are logical addressing, which means it is going to provide the IP address to the machine. Routing is also there, which means like if IP is there, so like if you want to make the communication from one network to another, so you must be having some routing protocol configured. And if routing is there, so it is possible that data forwarding will be there, because it is the main, like task of routing, that if you want to make the communication possible between one router to another, so that is why we do use the routing protocol. So that's what the working of your network layer is. Now we do have the data link layer, which basically encodes and decodes the packet into bits using its transmission protocol. Before that, see, guys, here we do have one concept which is known as framing. So framing is somewhat like, see, guys, as we have discussed the network layer. For example, this was your router, and you have a switch connected here, and this switch is connected to some multiple machines in your network like this. So if this router is sending, yes, you all know that router works on the IP address. So router is going to send some layer 3 packet. So like, which includes a packet, and packet is consist of IP address. So when the packet will reach to the switch, so as you all know that switch is a device which never understands the IP address. So basically, what is going to happen in that case, this data link layer is going to do some framing. So framing is somewhat like the packet is being converted into the form of frame, because your switch is not going to understand the packet. It is going to understand the frame, which is consist of MAC address. So switch always works on the concept of MAC address. So that is why we say that framing is done on this layer. And it also encodes and decodes the data packet and frames into the bits for its transmission control protocol. For example, now let's say we have this router which is connected to a switch, and this switch is connected to some multiple machines. For example, you all know that router works on IP and switch works on MAC. So whenever the packet will be reaching over the router, for example, this is your packet, and this packet is going to be on the router. So router will be able to understand that this is a packet which is having this source IP, destination IP. So router, like for example, this machine has requested. So router will forward that packet on the switch. Now switch is going to do framing for, like, because So it's never understands the IP. So like, it is going to convert that packet into the frame. Once it has converted the packet into the frame, so it is going to identify that this belongs to this particular MAC address and this is the source IP, destination IP. Like then it is going to identify this is the frame. Then after, like, it is going to decode that packet, because see guys, now these cables, like, like these cables are not going to understand your IP, nor they are going to understand the MAC address. So in that case, the encoding decoding happens here, like all the data which is coming from the switch to the machine. So in between there is a wired medium, and that wired medium never understands the IP address, never, nor it is going to understand the MAC, because as you all know, wired mediums are basically going to work over your electrical signals. So that is why it is said that physical layer is responsible for connecting the physical connection like hubs and repeaters, and the data is transmitted through electric voltage and frequency or pulses. So that is why we say that it is going to use the cables, and the data will be go through the form of electric signals. Now this is what all about the OSI 7 layers in a nutshell. So now see guys, whenever we are comparing the OSI model and versus the TCP/IP model, so in that case, guys, what we have to do is like, see, it's very much simple that OSI model is, somewhat consist of 7 layers, but TCP/IP model, it was introduced by Department of Defense. And the major difference between OSI and TCP/IP is OSI model is a reference model which is used for study purpose only. And whenever we are talking about the TCP/IP model, so TCP/IP model is somewhat a logical model which is practically being implemented in all the machines today. Like we are all using the TCP/IP model because of shorter layers, because the data will be like, the data flow will be faster in case of your TCP/IP protocol. And because we do have less layers, as you can see on the slide, like TCP/IP model was designed, developed by the Department of Defense, and this was developed by ISO, which is International Organization for Standardization, to make the communication possible between different vendors. Like if you want to make the communication between Apple to IBM, so that's why we do use the OSI model, but this is never being used in the industries. Like we always go for the TCP/IP model because of its, shorter layers, and it is also a logical model. So guys, the working which we have discussed in the OSI model, like it's same as in the TCP/IP model. But see guys, these application presentation layers, application presentation and session, these layers are consist of only one layer in TCP. This transport is referred to as transport layer, and this network layer we have changed the name to internet layer, and this data and physical layer are known as network access layer. So we have, it's basically also said that TCP/IP is the concise version of your OSI model. So like it was developed. See guys, now what happens in all these layers? Let me give you a quick brief. In your application layer, we do have the data, whatever the data you are sending. Then we have presentation layer. In the presentation layer, we also have the data plus extension codes. Extension codes like whatever the data you are sending, that particular data will be having its own extension codes. Then we have session layer, which is going to maintain the data or maintain the session, we can say, maintain the sessions. Then we do have transport layer, where we have two protocols, TCP and UDP, which are like, identification of your the data, what kind of data you are sending, like it's a text data or it's audio video signal, plus the upper data, which is coming from application presentation layers. As well as it is also going to check for the error control, like is there any error or not in the data. So for checking the errors, like we do have two algorithms, CRC, which stands for cyclic redundancy check, and checksum is also there. Now we do have the network layer. In network layer, as you know, that router is there, so packet will be there. Packet includes what? Source IP plus destination IP plus upper data, which is coming from the above layers, application presentation session, plus the TCP UDP protocol, because identification of data would be there. Now we do have the data link layer. So in data link layer, we do have frames. So, like when it comes to the frames, so we have source, destination MAC plus source IP plus destination IP plus TCP UDP protocol plus upper data, which is coming from the above layers. So like we have lastly the physical layer, where all the entire data is decapsulated, like the data will be, reach to the machine. So like this is, the entire process of OSI model. This is how the entire TCP/IP model is also going to work on the same model. So that is all about the OSI model, and I hope that like in a very short amount of time we have covered a lot of things in your OSI model and TCP/IP model. So these are some basic differences between the OSI versus TCP. Like you know, you do have the shorter layers, like you have only 4 layers in TCP/IP, whereas in OSI model you are having 7 layers, and it takes a lot of times to reach the physical layer from application to physical. But here you have only 4 layers, so that data will be processed in a very faster way. So that's all about the OSI difference, like OSI versus TCP/IP model difference.